So you will get a book here, icon as a book, something like this. Have you got it?
Yes.
Okay. So what can you do now? You can just grab the icon and put it, for example, I put it here, you see, on the right upper side where I have R packages. I can grab again this and put it back, you see, like this. I can just grab it and move it elsewhere. You got it?
Yes.
Okay. And this is Package Manager. Here you have the graphical user interface that you can actually install packages from CRAN. And you can see that you don't have to go one by one. You can just, like type it like CJ plot broom janitor. You see, I'm just typing them with comma. I don't need to go one by one. I mean, in the graphical user interface, because you could also install many packages at once with the code also in RStudio. Okay, so packages are now installed. You work the same as with you would see here you have search, what is refresh, update, loaded packages, and here you have a new packages. The documentation, sometimes it works, sometimes it doesn't. I mean, when you click on it, sometimes it will fire and sometimes it will not fire. Okay, but you have everything here. So I think that you have no reason to insist with RStudio. And it would be my privilege if I would be the one who would actually incline you towards the positron. Okay, because I think that the environment is much clearer, much nicer, much more. I don't know. Probably only Elise agrees with me. uh, am I right, Elise?
Yes, yes, you are right.
Okay, so now let's begin with today's session. Okay, the first thing I will ask Surya, what does echo true mean? Do you remember from last time with Quarto?
Uh, yeah, so it's majorly a mix of HTML file and R file where you can mainly define some criteria of
Yes,
the
that's true. But what does echo, that one?
okay, echo.
Echo,
Okay,
yes.
okay, true. Mm,
Does anybody else know? Don't you
Um,
remember? Yes?
Code is shown in the output.
The code is shown in the output. The code. Yeah, that's true. So the code is shown in the output. Warning and messages are actually self-explanatory. And we said that usually we also add error to true. So that, for example, in case of any errors, our rendering doesn't stop. It just keeps the chunking part which is causing the error. And it just continues until it produces HTML, PDF, or Word, or Reveal.js, or PowerPoint, or whatever. Okay. We will talk about CSV and the Excel files. Then we will go to more advanced topic. You all are familiar with CSV. You did some already reading with CSV. Am I right? So you are using the read underscore CSV.
Yes, read underscore.
Yes. Okay. You know that the base R uses read.csv and read.csv2. So we also have read underscore CSV and we also have read underscore CSV2. And probably you already know what read underscore CSV2 does compared to read underscore CSV. What is the main difference? Noah, what is the main difference between read underscore CSV and read underscore CSV2? Noah Labar.
Yes, yes. I don't know, honestly.
Come on. Now you are being involved with R almost for a month now, so you should know this like basics. Read underscore CSV is for comma separated values, and read underscore CSV2 is for semicolon. Okay, so if you have a semicolon, you cannot use read underscore CSV. What about Christelle? If you have pipe as the operator or tab, not pipe as the operator, pipe as the delimiter or white space as a delimiter, what must you use then to import data?
Uh, Sorry, I don't know.
Come on. Read underscore delim, where you can specify the delimiter on your own. Students, friends, colleagues, I mean, I would understand that this would be like a second lesson with R. I would understand regarding these basics, but since you've been learning now R for a month, I would expect that you know these basic functions. I'm not asking you something very, I don't know, advanced. I'm just asking you how you can read. So I know that you have AI, but you still have to know, like at least, okay, CSV, CSV2, read the underscore delim for if I have a special delimiter. On the other hand, I have write underscore CSV, write underscore CSV2, and write underscore delim. And I guess you didn't use any of those functions, right? Have you written anything to back from R to disk until now?
Yes, we have.
And you used what?
With underscore delim, it's for a file like .txt.
Yeah. But I mean, what did you use? Which function did you use to write data back to disk?
I'm sorry, I'm not getting your question.
Okay, one step is you're reading data into R, but on the other hand, you are writing data from R back to your disk to C part. Exporting data. Like here, look, if I go here, I have air quality.
They
Okay.
use something called WRIT, right?
No.
Okay.
You actually have to go with, for example, write. Okay, I don't have library reader. Great. So I don't have a package called reader. Let me install install reader. Okay. Okay, library reader. Okay, so this one is like this is tidyverse package that enables you to read and write data. So I have air quality, and I will export this to write. Why doesn't it show me? Okay, let me go here, reader. Reader, write CSV2, and I will say air quality.csv. No, this should be. Okay, so just click here on fix in Positron, and it will try to find the solution for your problem. Okay, so what did I do wrong? Reader of write underscore CSV. The package is installed. Okay, now it works and should work also with what I had before. So sometimes it just doesn't work. I don't know why. For example, this code is completely legit. Air quality and then reader. You see, now it works in script and it didn't work in a console. So what you see now, I actually used air quality and I have written air quality to aq.csv. So you will find aq.csv here, you see? If I click on this aq.csv, I immediately get, okay, let me just clean this. Okay. Okay, like this. So by default, when I have a CSV file, only by clicking on it, the positron will produce me with exploratory data analysis. You see, I didn't even imported the data. I just clicked on the data. Okay, I see the distribution, and you can see that wind has completely asymmetric distribution. Temperature is pretty much normally distributed. I also have all the rows. So yeah, that's it. As simple as that. Okay, so where is the console? Console here. And I don't know why I cannot grab it and bring it down. Okay, like this. So write.csv. And when you are importing data, I guess that until now you use the import wizard in RStudio. Am I mistaken? Like import data and then you choose the URL or you choose the file on a disk. Well, here we don't have, I think, import wizard. Let me see if we have import wizard. No. R import. No, unfortunately not. Auto import. No. I'm just looking. R tools, signature help, tooltips, and more. For Visual Studio Code. Okay. So it's not, I don't find any similar or extension. Okay. But we can live without this because you have something. You have something in base R. You can say choose, and then you can go choose files. If you put enter, unfortunately, in this case, the dialog box is usually hidden somewhere. You see, hidden behind. And when I first executed this choose file, I said nothing happened. And because I didn't know that actually the dialog box was opened in the background. Okay, so here I could then go and choose a file. For example, air quality, open. So now I did open, and now actually it is loaded into memory. Okay, so you can use the choose files. You can also use the choose directory. Again, you see, it opens the dialog box. This also works, of course, in RStudio. Okay, this also works in RStudio. When you are specifying the path to the file, if you will ever do something like this, and then you will start like, see, don't use backslash. This is a no, no, no. If you're using backslash, then you have to escape it. So it would be like this. Like, okay, like this. But don't torture yourself. Just use the slashes and you are on a safe side. It is the same in Python. Okay, just use slashes. The same in Python. Clear? You know that if you're using the RStudio and double click on the R script or on Quarto document, the problem is that you're not pretty much sure where your current working directory is. So you always have to rely on the session set working directory. And the get working directory function tells you where you're currently positioned. But with the principles of using projects, like I showed you with the RStudio, if you create a project, then every time you will double click on a project, you will be in the same folder where the project is set. Or on the other hand, if you are using Positron, where you open a folder, and with opening a folder, you create some kind of a project, you again know where you are positioned. So please if you are using RStudio, go with projects. If you are using Positron, you are on a safe side. Did any of the professors mention that positron exists? No?
No.
No.
What about the Quarto?
Yeah, today professor asked about it. like data mining professor Laura.
Okay, yeah, because last year I actually wrote to other professors, please tell students go with Quarto, use Quarto. So what? So you switched to Quarto?
No, she just asked if we had used it for a future asynchronous class.
Okay. And you said?
That we did it with you.
Okay. Great. That's a good news. Okay, so if you are with positron, then you're definitely on a safe side. When you are when you are manipulating with files, the best way is that you create, for example, a new folder inside your working directory and say data, and you put all the files in this folder. So, for example, now I put the air quality into data folder. So what does that mean? For example, if I'm here, yes, move, okay, then I can simply just say read CSV and okay, you see, and again, I don't know why, probably because here I would have to add, probably, I'm just suspecting this. Because this is separate library tidyverse. So this will be now inside of positron. And just to be on a safe side, let's go with reader. Okay. So where is my here? Now let's keep fingers crossed. And now it works. Yeah. So because this is isolated, Quarto is isolated from R. Okay, so you see now the data is in my, okay, let's go with the CSV2. Without any problems. If I am moving the folder into the data, changing the file into the subfolder, then I have to specify the name of a subfolder before I am importing data, like data, and then the name of my file. You see again, the data has been read to my session. Is this clear? So you didn't use this kind of a code, I mean manually, you didn't manually import data to our session, or did you or you didn't?
Manually means you are just entering the data into the table.
Yeah,
Yeah, we did it.
but what, with the import command or manually?
Import also used, manually also used. Depends in the few of the cases.
Okay, so now I will run tidyverse in read Excel. You know that the read Excel is the tidyverse package for reading Excel files. This is only for reading, and on the other hand, you have a library write Excel for writing. Okay? So you also can write back data into Excel. You see, for example, let me create my empty cars, and I will say write XLS X into empty cars dot XLSX. And voila, the data is here. I can open the data. Okay, so this is not the correct one. I can now simply open the data. Okay, simply open the data. And not only this, you know what I can do? For example, more complex operation and by writing. Okay, I will create here a new folder called empty cars. And my idea is, let's say that I would have something, some data that I should write in batches, okay? In batches. For example, I will say for I in 2010 till 2019, okay? I will do something. You know this for loop, so just a little bit different syntax from Python. We have to have normal brackets where we have our condition, our clause, and with curly brackets we define what is part of the for loop. Now I can, for example, do this. Look. Are you familiar with the mutate part? You are.
Yes, we used.
Okay, so I will say here year. Okay, and I will say that year is equal to I. Okay, so would you agree? What will happen in this case? When I say empty cars and then mutate year equal to Y. What will this part do?
Just modify, right?
It will add a new, okay, I will say right here 2010. Now look. Okay, we get a new column called year. You see?
It's actually modify the table.
Yeah, this is data frame. Okay, so now I will write here the name of a file, a name of Excel will be. So we have, I can go with strc. This is concatenation. Are you familiar with this one?
Used, but
Yes.
specifically if you just can mention what is the benefit of, like, what is the function of using it. You will take it.
Okay, so this is like for concatenation. So I need this part. I will write here I to 10. Okay, then I will have my I and I will have my dot xlsx. Okay, and the separator will be empty space like this. So if I now execute this, okay, am I missing something? Separate, yeah, I am missing comma here. Okay. if I show you this part now. Okay, so we get a name empty cars underscore 2010.excel file. Okay, do you agree?
Yeah.
So in every loop, I will be different and we will get a different name. So then I'm just trying to use this one. Maybe this will fail. Okay. Like this one. And I'm also getting so that I will write this into the empty car subfolder. I will write empty cars and slash like this. Now let's see what will happen. So already it's done. Now let's look at our empty cars. Voila. You see? So now I have the files in my folder. And if I go here, empty cars. So let's say 2011. 2011. You see? With just a few lines of code. But this is not even the most optimal code. It's just a little bit longer so that you can comprehend the simplicity of what we actually do. We just go for, we are adding the column, and then we are writing the file to to our folder. If you are not sure, you know that you can always click on, where is the explain? Okay, let me go and explain. You can always click on the explain and this one will, personal assistance will kick in and you will be able to get also the AI explanation. Okay. So it says, name Excel packages you loaded are diverse, is impacted, you wrote and ran for loop, and that's it. Is this difficult to understand?
No, it's fine.
Okay, for you, but what about others? Can you please give me some feedback? Is this very difficult to understand?
Professor, one more thing I just want to ask you. That
Yes.
empty cars Excel files you were taking externally. So in RStudio, I think we have a inbuilt package, right?
I think that yes. I'm not really sure. Yeah.
Yeah, I think today we used. So that's why I
Yeah.
asked.
Okay, let's continue. So, write CSV, we already explained. And let's go to check the data. Glimpse, you know the function glimpse?
Yes, we used in our.
Okay, you have glimpse, you have summary. You have, of course, more advanced packages. For example, if we load the package psych, see, okay, let me just install CRAN. I think it's like, no, PC. like this one. I think it's like this. Let me see. Yeah. So psych. Okay. Let me load the psych. Okay. And let me show you the documentation. And you have summary DF, if I'm not mistaken. Much more comprehensive statistics than how is describe? I'm mixing a little bit. Is it describe? Yeah, describe. Okay. So we can use the describe. Okay, and let's take the air quality. And you see you got much more comprehensive statistics than with basic summary. You get n, mean, standard deviation, median, trim, mean, max, range, skew, skewness, kurtosis, and standard error. Okay, so this one is also very nice. I will show you another one. This is called, I will open the R. This is called Skimmer. So please install the Skimmer viewer and we go to Skimmer. If I say library Skimmer, and then I will say skim is the function from the air quality. Okay, this one is much more comprehensive. Now let's execute this. So what do I get? So basic, you see, basic statistics. So number of rows, number of columns, what you get with glimpse or with dim. You get how many columns are numeric, then character or Boolean, and then the statistics. And let's say primitive histograms. Primitive histograms. But it's, for example, it does show you initial distribution, like you can all immediately see, okay, this one is skewed, this one is pretty much normal. So it does, just like, like with Python, with SweetWiz or with Y data profiling, you can also use this. Why did I tell you that positron is much better than RStudios? If you press Shift and I, probably in Mac it is Command and I. Okay, let me see if there is no Shift and I. Okay, you can just ask Assistant. For example, I will say create a function that will check whether a number is odd or even, and then use this on a random sample of 100 numbers between 1 and 1 million. Okay? And nothing happened. Because the whisper is not actually on. Okay. create a function that will tell us whether a number is odd or even and test it on a sample of 100 numbers between 1 and 1 million. Nothing. Buggy application. Okay. Test if a number is odd or even. Test it on a sample of 100 numbers between 1 and. Okay, so we did ask our assistant. So this is our function, and so you see is numeric, and then this is modulo operator, a little bit different, so 2% signs. Okay, so we get here true or false back. Then this is a sample of 100. This is a sample on from 1 to 1 million and the size of 100. Okay, so if I execute this, it's a little okay. Why don't I see this here? Okay, let me put this into active. Like this. Okay, if I ran this part, okay, I get, you see, 100 random numbers between 1 and 1 million. Okay, so this is the sample dot integer. The replace false means that we cannot pick up the same number that was already picked up, that already is in our sample. Okay, and then we just create what? A data frame where we specify everything. Okay, now, voila. So how would you count how many numbers are odd or even? Milan, Tapa, how would you count? How many numbers are odd or even?
So by dividing it by 2, we can find out the even or odd.
No, it's much more simpler. You would just say result, and we will use one count, and what is the name is parity. Voila. So count is a tidyverse operation for creating the frequencies. So instead of like, the old way would be like grouping by parity and then using the n for counting. With count, you just say count and it counts. So if I run it again, because it's this one. Okay, so you see it is nearly, okay, so in the long run, this would be like 50-50. Okay, probably it would be 50-50, so. Any questions? All clear? Christelle, do you have any questions?
Not for now.
You understand everything?
Yes, but I need to practice after the class.
That is mandatory.
Yeah.
Okay, you have enough time that you can practice. You have enough exercise that you can practice. Okay, so with different separators, we already talked about this. We use the read underscore CSV2 for the semicolons, which is the European standard. But if we have something even more exotical, we use read delim, okay? Where you specify the separator. That's it. Now, regarding the missing values, okay? I know that this is a little bit counterintuitive because usually when you get data, you do the exploratory data analysis and you check the ratio of missing values. But sometimes, if you know in advance that what kind of a data are actually meant for missing, you can specify the NA value. NA value where you can list all the values that actually mean missing values. So where are you? NN. See? By default, we have empty space, NA, null. We could, for example, also say, I don't know, absent. In this case, we have three types of missing values, as I already mentioned. And if I run this, okay, you can see that this one is now NA, 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 NA. Now I will check, replace -10 or -99. Okay, now I will also add here -99. Okay, run. Again, you see NA, NA. So it's already immediately done. When you are reading the data into R, you already specify the missing values. So you then don't have to go and then, like do it. Do you know how you would do this, let's say, without this? If you only had if I omit this, and now imagine having many rows and many columns. How would you deal with and apply NA? Was this taught? Did anybody tell you how to do this? For example, how would you now that say that -99 is NA missing value and null is a missing value?
Professor, can we use mutate and store any?
What would you use?
Mutate.
No. It's pretty simple. So you, for example, say you subset grades, and in the grades you would say equal -99. Okay, that will find all the minus 99 values in a data frame, and then you would assign where the minus 99 would be found, you would say this is NA. Also for null. I don't know if null is actually treated. Okay, so now let's do it. And see grades. Voila. You see? So this is the old school code in Baysar. When you say find all the grades in the grades folder, grades data frame, where the grades are equal to minus 99 and the grades are equal to null, and replace them by NA. So we get this. Usually when I get a data, like here in Slovenia, we have one very famous, nationally famous dashboard where researchers can set the survey. It's called ENCA. It's also available in English. It's also available in English. Okay. And when you get the export, okay, where you have empty values, or where the people didn't vote, or exited prematurely, they get numbers like -3, -2, -7, like everything, something that means a certain act, but it doesn't have any value regarding your research. So in that case, when I get, let's say that this would be grades, I would just say if the grades are lower than 0, for example, all the minuses, just treat them as NA. And it's done like this. And I can continue working with the data. Okay. So then sometimes you will encounter a problem that the R will guess the data type, column type wrong. So here in our case, we have ID, zip code, and amount. Okay. And you can see how the zip code is specified. This will not happen all the time. It does sometimes happen. So you see 0, 1, 2, 3, 4, 0, 0, and 0, 1000. Let's put this into orders. Okay. And if I only go by classical redos CSV, sometimes it will happen that this will be converted to numeric data type. Okay. Sometimes, not always, but it can happen. That's why you have the possibility to specify the column types when you are importing data, so that R is not guessing, and that is faster. This is also faster. Okay, so I'm saying that ID is integer, zip code is character, and the amount is double. Okay, and this is the right import. In our case, we get the same result no, not the same, because in the first one, the ID was actually the double, the float. But you see, it is more precise when you want to control so that R is not on its own, then use and specify this. Okay? Clear? All right. So you can practice this. Okay, for example, let's look at this one. Let me see what will happen in this case. Okay. Let me now click on the, what do we have? My products. Okay, so they weren't actually transferred into converted into different. But I could say, for example, when I read this, let me use this. My products. Okay, so we have the product should be character. Then we have price. Okay, it should be double. And the last one will be in stock, and I will change this. In stock. And I will say call integer. What's wrong? Is it, let me just see. Question mark, call integer. Yeah, it is. So what seems to be the problem? This is just a warning, okay? Not error, okay? And it was all transformed into, yeah, into NA. That's strange. This should be definitely converted to ones and zeros. Maybe. Call. Let's go with call number. Maybe. No. So see, now I would probably have to do this in the mutate part. So to actually transform this into ones and 0 and 1. Then the Excel. Are you mostly using the Excel files or the CSV files in other courses, in data mining course?
Using both Excel and CSV, mostly CSVs.
Mostly CSVs. Okay. In the past, I did quite a few applications where I used the OpenXLS library. Let me install it. Not yet. Install. Okay, so we are installing the OpenXLS. This is the old library, very old library, but it has something fantastic. With this library, you can actually manipulate the object of the Excel. Okay, so what I'm doing here, okay, so I'm firstly calling the library and see I'm using the create workbook. Now I'm using I'm now in Excel and I'm creating a workbook. So just like I would run Excel, create a workbook and add a worksheet. You see, this one is called sales on a you see, on a workbook, it's called sales. Okay. Now edit. Okay. Now we will add the second one called product and we write it. Okay. So now if I at the end say save workbook, I've created my company data, Excel, completely out from the R. So you can use the OpenXLS library to create your own Excel file. So list 1, list 2, list 3. Okay. And this is completely legit. Voila. And voila. Okay. So how did you read the Excel files until now? For example, if the Excel file had more than one list, how did you do it? Come on. You said that you are using Excel quite a lot. If I call read Excel from a read XLL package, which list will I read? The first one by default. So it should be sales data. Here they are. Okay. If I want to read the second one, I can say list sheet products. I can go by name. I can say products. Like this. Or you could say instead of name, you could specify the index. Like the second one. Voila. But of course, this is not the best way. Okay? This is not the best way. For example, let's try and think of, let's do this in an old school. I would say for, okay, sheet in, and I will let this one. Okay. So we get the sheet. So what can I do now? I can take, how do we create an empty list in R? Guys, come on, these are basics, please, please. These are the basics. How do we create an empty list?
My list.
Would you say something like this? No, this
My
is
list,
Python.
right?
You just say list. Okay? I will say here, yeah, my list, that I will not like this. And I can then say my list I will put into the and is read. Okay. Maybe it will fail. I don't know. I'm not sure. Okay. And my list. Okay, let's see. Yes, only a warning message. Read Excel. No, this is not the correct read Excel. This one is fine. Hmm. Why do we get only January, February, and the widgets only the first column? Oh. Excuse-moi, my mistake. Voila. So you see, with one little procedure, I read all the data into my list. And once a data is in this shape, how would I, for example, subset the price column of the products element, Shen He. How would I get the prices?
Hello, Professor. You should use the list and then use quote mark price.
Oh, once again, okay, so the first, okay, once again, so you would write what? My list.
Mm,
Then?
and sheet.
No. This is the name of our element, you see? So
From
how do we subset? How do we subset the list? This is something that Professor Balash told you. You use a dollar sign if you have names. Otherwise, you go with like this. Remember? Okay, and then how would I get the price? Also, it is the second one. What is the difference of subsetting? What are the differences? Yusuf, can you tell me what are the differences between these two expressions? No? Okay, so if we have a simple list, this one will always keep the same object type. So this one will always, so the result will be always a list. In this one, not. Okay, so let me execute. It's still a product. Okay, let me execute this one. No, this one keeps the, yeah, this one keeps the list. This one is actually now transformed into regular data frame. So the first one is still a list. You see? This one keeps the list. This one transforms it into its own data type. So if it is vector, then it will be vector. If it is nested list, it will be a list. So you have to be very confident and skillful regarding subsetting, because most of the time you will deal with garbage data. Most of the time you will deal with garbage data. And you will have to do something, I don't know, some subsetting, preparing data. And you have to know this. For example, let me create a new file. And I will ask, create a nested list, complex list. Okay, let me put this into, okay, add cursor. Close. So now let me see what we get. Okay, so if I now enter, okay, so this is now a really complex one. How would you, for example, get back the last element or the mixed one out of this complex list? Or maybe that one. What kind of object is this? Which object type?
Is that a list, Professor?
No. No. Noah, do you know? Okay, no, I already asked you. Aya. Okay, sorry. Liao Yu Xuan. Which object type is this?
Data frame.
No. Come on, guys. These are like, okay, which data types? Four essential data types in R. Which are the four essential data object types, object classes? Which are? The first one is vector.
Vector, matrix, list, dictionary,
And dictionaries in Python. Matrix. Yes,
matrix.
so this is a matrix, what I'm having. It's also the name. Okay, it's the name there. Okay. So how do, for example, would I get back the C column? How would I get the C column?
So it's going to be start from 1. It's not Python like 0. So we have to define 3 number.
No, because it's not necessary. So why? Because we have names, we have data types. So if I, for example, write here complex list, and the first one here is data. Do you agree? And the second one is matrix. Okay, so it will be data, then it's a matrix. What about then? C column in matrix. How do I get it?
0, 3.
Oh, just like this.
So inside the bracket, it will be comma C.
Yes, note, yeah, because it is a name. Let me see if this will work. So because it has a name, it should work, and it works, you see? Because it has a name. Otherwise, usually metrics don't have names by default. So you can go by position, and it's the third one, okay? And once again, you see, we get a vector. Let me see if this will work. No, it doesn't actually. Okay, we get vector. Why we get vector? Oh, please. Now I'm a little bit disappointed because these are the essentials. What happens when you are subsetting, for example, single column in data frame or matrix? It happens that subsetting process will try to return the simplest possible object, which is vector. It will do this by default, but you can always say drop false. Okay, that means no, it's that means that it will preserve the object. In our case, it preserved the matrix. So we got the result as a matrix. Do you understand this? These are the essentials. It is the same as in data frame. For example, let's look at the empty cars. Okay. Now I want to get back miles per gallon. And if I will say, miles per gallon, you see what I get? I get a vector back. It dropped the original object type and it returned the vector. So I have to say drop to false. Oh, come on. This is really now annoying, this AI. And in this case, it preserved the original object type. So you have to be careful when you will manipulate data. You have to know these things, you know. For example, maybe you would do like this, and then I don't know, I'm just guessing. What would be the only data frame? C. Okay, I don't know. I won't even guess. So you have to know when your object type will be replaced with vector. Okay? I think that we deserve a break for 15 minutes. What do you think?
Yes, Professor.
Module 2. So we talk about the subsetting lists. And now let's go and read the data at once. Okay, so you remember that in the beginning of today's session, we talked about writing the empty cars into the folder with specifying 10 different years. So we actually created a new column year, which in every loop changed. So now let's do this and in reverse. Before we will also do the reading of all the lists at once in a bit different way. Okay, so before what I did was using the for loop. Okay, this one is more advanced. This one is tidyverse. Okay, so I have to again load because I tidyverse, and I have also no, only tidyverse probably. This is enough. Okay, so what do I have now? I'm reading. No, I have to also load read Excel. Read Excel. Okay. We read lists into sheets variable. So we have what? What is this object type called? Surya. This one.
Uh, it's a data frame.
No, data frame has columns and rows. This is the
Mm.
most simple one. Vector.
Vector.
Okay, now look this magic. Okay, look this magic here. So we are then taking the vector and we are applying set names. So we are actually adding the names. Look, the names, you see? This is now named vector, okay? And what do we do then? We are mapping here the read Excel to every element of this vector. This is called functional programming. So instead of writing a for loop, I can map a function, and this will do like internally, it will do the loop. And this is much faster. This is called functional programming, and it is one of the most popular ways right now how people are coding. So function, you see, and map. So internally in every loop, I will change .x. So in the first loop, it will be sales. And in the second loop, it will be products. Okay. Now I will show you how you can use the same principle by reading all empty cars from our folder. I will insert a new chunk and I will say list files And what I want to go into data empty cars. No, it's empty cars dot empty. No, it's empty cars like this. Like this. Okay, what do I get here? Again, this is a vector, and I can just take this one. I will change here into map DFR. I will explain this later. And I will read this. This should work. Empty cars. Okay, so it's strc. Now here I can say full name equal to true. I think it's like this. Let me just check. Help. I forgot. Okay, full dot names, true. Full dot names. Okay. Run it. Voila. And all the data, you can see 320 rows are read at once. Read at once. This is the most efficient, the fastest way. Of course, if you go with Baysar, it's even more fast. But this is the fastest way and the most elegant way how you can write a code for reading the data. I will now explain what these map functions are doing. Okay, I will open a new file, R file, because this is very important. So it all has a basis in Baysar and with the apply family functions. Apply functions. And the most important one from this family are the sapply and lapply. Okay. Now they won't create me already the example. Okay. So I have here X. Okay. Let me look at the X. Okay. So I have, what is this data type called? Xiong Shaolin. What is this data type, object type called? The Sousa Miron. Come on. How many times did we go through this already today? So these are the basics. Which data type is this? Come on, guys. Look, it's a list. Yes, a list. Probably you wanted to say list. Okay, so what if I want to immediately calculate the mean values on all these elements? I can use lapply or sapply. So if I use lapply, okay, that means I will go through every element of the X and I will apply the min function. Look, I got the results. Now if I use the sapply, voila. Okay, so what is the difference between these two functions? Alavia. I hope that sorry for pronouncing probably the name wrongly.
Yes.
Okay, so what is the difference between these two types? lapply and sapply. What is this object type here? And what is this one?
For the lapply, I think it returns as a list,
Yes.
and for sapply, it tries to simplify the output. It's still list, but simplified.
No, you were correct with the first part of your answer. It tries to simplify. So what is the simplest object?
Oh, the vector.
Yes. Yes. Okay, great. Thank you. Yes, she was completely correct. Lapply, as L implies, will always return list. The sapply will try to simplify the result and it will try to return vector if it is possible. Otherwise, it will return list because list is the most versatile object in R. It can hold everything, okay? Everything. So this is base R. Base R, okay? Functional programming. Remember this. This is something that you will be probably asked on the interview. In the interview. So, and then we have tidyverse pur package that does the same, just in a tidyverse. And map. So we have map. Map will return probably a list. Then you have map, you can go double. Okay, so what do you think that this one returns? Map DFR. What do you think? What do you think DFR stands for?
Data frame.
Yes. For example, look, now I am creating a map DFR. I am applying the min function on the X, okay? And I'm getting back a data frame. I could say map list. You know that I will get back list. It's only map, okay? Not list. Map. I get back list, the most simplistic one. If I would go map character, why not? You can always go from a number to string. I thought that this will work, but it doesn't. Okay, so because you get back the strings, I don't know why it cannot return back a string in this case. So these are the functions where you take object and you apply a function to this object. So for example, you can create a function. I would say dummy functions, dummy function. And I will say in this dummy function, so this is a syntax for a dummy function. So it is actually the same as in Python, just that in Python you have def and then you specify the name. Here you have a name and then you specify the function and the parameter, okay? And I will also create dummy vector, which will be 1 to 100, okay? Do you know what I will get in this case?
From 1 to 100.
Yeah, so vector of oh, I'm missing that one. Okay, so if we look at this one, I'm getting the numbers from 1 to 100, okay? And I have here a dummy function, and I will say return y multiplied by y, okay? Like this. So I take map and I will say double, okay? So it could be integer. I say dummy vector and dummy functions. Voila, you see? This is the fastest way that you can program in R. The fastest. When you have million rows of data, you know, it really counts how you write your, let's say, your function. It really counts. Okay, so these are called vectorized operations. And you can use these map functions inside of a tidyverse, which really speed up the process. Okay? So now I showed you how you can actually read the data from a folder with the help of a list.files with full dot names to true, so that you get names like this one, and then you just apply a function read Excel int map dfr, so you get back the data frame the fastest way and most elegant way. Would you agree?
Yeah.
Do you prefer this one or that one that I showed you before, like with for loops? With for.
Using for, it will be quite complicated sometimes. But if it is not necessary, why should we go for loop?
I mean, the for loop is really, I think that for loop is actually, you know, it's slow. It's not that fast as this one, not nearly as fast as this one. Okay. Sometimes this is the nightmare of everyone, of every data scientist. When you get data and you are so happy, okay, so now this is my first project, I will import data and do the analysis. When you have a special data, like accent sensitive, for example, I know that like China has its own characters. Slovenia has its own characters, which are not part of the core ANSI standard. Okay, that's why we have to use UTF-8, and the Asian languages usually have to use UTF-16. So, for example, people from Asia, if you will get a data set which will include your own data and it will not work, change the encoding to UTF-16. Look, UTF-8, this is UTF-16, okay? AI modes. Okay, 16 specific Asian, you see? Chinese, Japanese, or Korean characters. So you have to go with UTF-16. Have you ever encountered this kind of problems? Anyone? Apparently not. Okay. Then you will have the parse numbers, okay? So when you are importing data, you will have the prices, like in this case, you see the dollar signs. How did you actually dealt with this in the past? Anyone? Does anyone has any experiences with this kind of data?
I have personally this problem with my final project in Python. I
Yes.
don't be able to put it correctly, just the numbers, and I need to delete the dollar sign.
Yes, Elise, but you could also, for example, you could use something very similar like this that you can parse. For example, you see here we have dollar signs, and if I glimpse this in raw, so this is treated as character, okay? And when you use the mutate and the parse numbers, which is in the reader, I think this is in a reader, I think it's from reader, package. Yes, it's from reader. You can mutate just parse, But I think that here we will have to add s character, okay, because like this. Let me see if this will work. Okay, also the quantity as character. Voila. And it is done. So with parse number, voila, we actually parsed the text into the numbers. So what will happen if I have here, let's say, an error? Okay. Okay, like this one. And like this. Okay, again, this is a bug of Okay, no, this one is not the correct one. See, probably it gives me an error, but I don't see it. No, actually it parsed. So you see, it parsed. Just a number. It took just a number. That's great. Only a number. So it ignored the A. We only got the number. So this one really helps a lot. Okay, so we did this. Let's clean this up. All of the files. Okay. Also clean the data. And now we will go to more interesting part. Okay, sometimes if you will really like to, let's see if I have this one. Yes, I have it. If you would really like to shine and show the potential employers your knowledge, you would have to do some kind of scraping of data. We will do something very, very easy. We will read a Wikipedia. In Wikipedia, we will then only exclude the elements with the table, so tables, and convert them into tables, the right tables. So we will look at the elements. Okay, so for example, if I go to 100 tallest buildings in the world, okay? So this is Wikipedia. Do you see anything, okay, different on, for example, can you spot something? This and this. If you click on right click and inspect, you come into the developer session of Chrome. So if you will ever deal with web scraping, this is something that you will have to do so that you will be able to look behind the scenes. So what do we have here? Okay, so if I go under the table and click again on the table and inspect, you can see, okay, we have here table. So actually when we have a filter in our tidyverse for table, we are actually extracting this, all this, okay, all this. See, there are many tables, but this one is the main one. This one, so it's the second one, okay? Do you understand? Right click and inspect. And you come to the table class. Now, let's take our URL and go into Positron. So we will replace this one with this. I need that one. Okay. And we said that this will be a second table based on what I saw in what I've seen in behind the scenes. Okay, so now if I run this, look what I get. Okay, so the first one is definitely not something that I would like to. So I would certainly try to avoid the first. So I will create here a filter where I will say name is not name. Okay. Name is not name. So cannot transform filter with NA or okay, so empty names. So I have to, yeah, empty names. Let me again go under the data and write the data. And look at the column name. So the first one is the problematic, you see? It's empty. It's empty. Data is a little bit messy, but nothing that we can't actually fix. So what we will do now is we will take, now this is something that you don't know. In the select statement, you can already do the renaming. So I will say building is equal to name. Then height. Okay, so this one is really messy. I will put it in single quotes. Is this one. This one is messy. And the last one will be country, which in the default is country. Okay, now I can say here building voila. Okay, and let's look at the data. Voila. So we have 97 rows and 3 columns. But we have to do something. Elise, what do we have to do if you look at the data? I would like to actually calculate the mean height by countries. So what do we have to do? If you look at the data, is there something that you notice?
I don't know.
Look at the data types.
To put it in double because it's in character.
Yeah. Okay, so we will put mutate here and say height and okay, so parse number height. Voila. So in a few lines of code, we have just come from extracting data from Wikipedia, extracting table, renaming the columns, and parsing the height. So I will here remove the building from. How is the easiest way to remove a column with tidyverse? Zank Yannick, how is the easiest way to remove the column? Come on. Students, come on. These are the essentials. How? In select statement. How do you remove a column?
We put skip
No, just minus.
minus.
Minus. So okay, so what's minus building and object building? Okay, building. Is here a problem that this one does not find it? Select minus building. It should work minus, definitely. Okay. That's strange. I've used this code like a million times. Maybe the positron has some problems. Let me check and see. Okay, let's run cell. Wow, now it worked. Okay, apparently it's I had to refresh. Okay, so now we have it. Minus billion. So we only have height and country. Okay, so how do we calculate the mean by countries? So by, how do we do it? How did you do it? Now many times. So you did what? Which verb?
Counts.
Which one?
Counts.
No, a count will only count the number. So if I say count, I can tell count country. This will give me the number of buildings by country. Okay, why is this going out of memory? No idea. So this one returns the number of buildings by country count. If I say group by, you said that you already talked about the group by. You did or not?
Yes, we did.
Yes.
And you see again, it cannot find, I mean, that's, okay, let me just again load tidyverse here. Okay, so this is really, really odd. Definitely bug. Okay. If I run cell, it's group by. See, again, it doesn't find the country, though it does exist, and now it works. So apparently something wrong with the memory. Okay, so so what do you see? What did we get back? Now think, what did I tell you in previous session? What did we get back? What is this object type? Is it a data frame? List? Matrix? What is this?
It's a list.
No, this one is not a list.
It's a data frame.
Data frame, a table, okay?
Table,
It
yeah.
says. And it says here that I have 14 groups. So I have 14 different countries. And now inside of this, I will use which verb to do the calculation of average, of mean? It starts with the letter S.
Summary.
Summarize.
Sorry, summary.
Okay, and I will say mean height. I will say mean of the height. And this will not work now. Again, you see, it doesn't work if I just call these separately. So I have to run all. And how do we do the sorting in tidyverse? Which verb starts with the letter A?
Ascending.
Arrange. Didn't you talked about arrange? In descending order, height. Okay, run cell. Descending order. Height, mean height, mean height. Like this. So in Malaysia, Taiwan, and I could also add here the number of buildings. How do we count in summarize verb? N. Do you remember this? N. Number. Do you remember?
Yes. Yes.
Okay, so in this case, we got country, mean height, number of buildings in a country, sorted by the mean height, okay? And this is the old code. This part is the old code. So if you want to be up to date, we can change this. Instead of group by, we don't need group by anymore. We have a special operator in a summarize called dot by, and we say by country. So you don't need anymore to write group by. You just use dot by in country and you get the result. Much cleaner, much nicer. I use this all the time, all the time. Is this did you talk about the dot by parameter in summarize?
No, we always did by group by, I think.
Look, you have to practice this. I mean, because these are the basics. So for example, I just wonder what are you now talking about in the data mining class? So last time you did the principal component analysis. What about today?
We did clustering.
Clustering.
Yes.
Okay, so this is unsupervised learning. Did you mention that? That this is unsupervised. That means that you start randomly and then calculate the distances and then you move like the centroids to different places once they are positioned, let's say, further from each other, but they do include samples, units that are very similar. Okay, these are clusters. You have two types of clusters: classical and hierarchical clustering. But yeah, I mean, this is probably what we do here is much easier than what you're doing right now with data mining. I don't know what's your opinion.
Yes, concept-wise, definitely.
Yeah, here we are just like moving data and preparing for clustering, for example. Here are just like you could also talk with the Google Sheets and also the Parquet. We already talked about this in Python. So this is the very compressed comma separated value file type. We did this with in Python with pandas who can actually read the Parquet data file. Okay, so web scraping will really help you. Now I will show you one example of the web scraping. Okay, it will be a little bit more advanced. Okay, I will load tidyverse and I will load reader. Okay. So what do we have? We have a special box office mojo. And here you have yearly reports. For example, let's look at 2025, okay? Now, I would like to get the name of a movie and the total gross, okay? Total income. So how should I proceed? I will here just copy this and go back. And I will just copy this because this will be the same. This here will be completely the same. Where are you? Where are you? Okay. Don't save. Don't save. Oh, come on. Oh, here. Okay, so if I take this URL, okay, so this part is the same. I just have to know which table it is. If I now look at the tables, okay, so this is main. And let me click on the table. Main, table, table, table. Okay, it's the second one apparently. No, it's the first one. Okay, actually the first one. Okay, so instead of, like before we have tables, I will take the first one. Now let's see. Voila, the data is here. Okay, the data is here. What I have to do is just select I will say movie, which is currently a release. And I will say income, which is currently total gross, okay? Let me see if this works. Again, here we have glitch in console. Okay, so we get a movie and income. Okay, like this. What do we have to do?
Convert the character to
The income,
double.
we should
Yes.
parse number the income, okay? So the AI is already here. And if I now parse it again, voila. Voila. I have the movies. And I can also say arrange descending by the income. And that will be, okay. So Wicked, Moana 2. In 2000 and, which one? 2025. Minecraft. I must say that I watched only this one. What about you? I'm not into Avatar, into okay, I don't even know what that is. Utopia, Lilo and Stitch. Probably this is cartoon, because I know that I took my nephew and my niece to Moana 1. Okay. But do you see something? If we go back and change the year, what can you see in the URL? Look what happens here. Okay, so apparently only if I change this to, for example, 2018, I'm getting back, I will say, instead of a range, I will say, yeah, okay, for now, let's just leave it like this. At top 5, okay? So top 5 movies every year. So what, for example, if now I would like to get back top 5 movies from all the years 2010 till 2010 to 2025. Definitely, I would write this as a function. I would say get top and movies. Okay, I can also, for example, it's already written now, you see? It's already the AI already wrote now the function. So what do we have here? I will put year inside this URL. I will get data, and I can also pass the 5. So like top 5. If I don't pass anything, 5 will be taken as the default value, okay? Now I can do map the data frame from, let's go with search 2010 to 2025 and get movies, get top 10 movies. Okay, yeah, arrange by income. Range by year, now by income. Like this. So this will be 30 top movies. Okay, so now I'm actually getting movies for every year, since 2010 to 2025. I am okay, so this is now the result. Arranged by the income. Okay, so I should say descending order. Again, let me just run it. I don't know why there are duplicates. Okay, there are some duplicates. I don't know why. Okay, Star Wars. The best one. I would say here distinct all. Okay, like this. So I will get the distinct values. Okay, Star Wars, Avengers Endgame, Spider-Man, Avatar, Top Gun, Black Panther, Avatar, Avengers, Inside Out, Jurassic, and see the income. If I would go also a little bit further in the past and say from 1980, this one is a large operation. Probably Star Wars will be again the most lucrative. So now it's going to the web page and scrape the data for every year. Okay, so we have 101. So you see again the Force Awakens, well, they're actually the same. Okay, so this is, you see, with this, I could analyze all the best movies from the year 1980 to 2025. This is all you had to know. This is, I mean, this is something new from today, and this is something that you already should know.